Hello guys, welcome to this video. I have my lemons that are mature. These lemons are mature. So in this video I'm going to show you how we can classify that lemons by using a color histogram. So now, first I need to segment these lemons. To segment these lemons, I use this sequence of filters. First, I've received the batch. Where are my lemons? Inside a for cycle, I process all the images. First, I read the image, and if I want to, sorry, this is bad. First, I read the image. After, I convert the image to grayscale, and also to HSV space color. And after I applied a Gaussian blur filter to try to up the fine details, fine borders. With this process, that details will be upped, more visible, more contrast, and then I applied a pass down filter. The feather blur can help me to show the image. Sorry, I speak Spanish. I can't say how I can say. So let's. I'm going to show you how it works. Oh, sorry. Original is not defined. Original. I need the original image to apply a mask. Sorry. I don't know what happened. But if I use a small blur filter, I got the results. But what happens if the kernel of the blur filter is very high? If that is very high, you see that therefore I use a small blur filter, fitting. After, I apply morphological operations, dilatation and erosion, and then I extract the value of the thresholding. The thresholding value, I get that value using Mahouta's library with algorithm. Oxus algorithm can give me the value of the binarization of the current image, and then I use that value of the binarization that there is holding. I use this value to separate the image from the background. Here I use this method from OpenCV threshold, and here I got get object from the background, and then I apply the mask to there's whole image, putting the original image in the binary image. I'm going to show you what happens if I only use this image. You see that the lemon is in white color. This color will be replaced by the original image. Therefore, I applied a mask. The mask is the binary image, and the image that will replace this mask will be the original image. So now, therefore, here we have an algorithm, sequential steps to segment lemon image. So now I will need to save this image in the disk to send the structure features. I'm going to stop it, and we are going to create a model that the blend that agree to use save this image that were segmented. I copy this code and I paste here. Here I have this class segment dataset that will receive preprocessors to resize the image, basically. And I will receive the patch of the dataset and the patch for the out image, for the out dataset with the correct segmented image. And here I made the same that I explained before, but with the difference that I apply preprocessors to resize the image. To save the image, I require the name of the image. I get the name with this line of code. Basically, I am reading the name of the folder. I have my image in the folders. The first folder is the mother image, and in the second folder are the green image. And here I am running this cycle for to read all that image and her name of the class and her name. First, this cycle read the first folder, and after it read the second folder and of sequential weight. And therefore I get the name of the label of the current image I read here, and I put here the label and after I concateno as guion plus a number and the extension GPH, and I write this image in the disk. Therefore, I is how I saved all my image. The processors, how I send preprocessors, where we are going to send preprocessors. So I'm going to create a model. We are here. I'm going to create a new model, new folder. FretLab, and inside FretLab I'm going to create a folder that is called, that I'm going to call home dataset. Inside dataset I'm going to paste it, new file and segmenter. Here is our library that will segment all the set button, but also I need the processors. How I send preprocessors basically is easy. I have for here from here simple preprocessor is very easy. We are going to create new folder, preprocessor, and inside preprocessor I'm going to say simple preprocessor. I paste here simple preprocessor library class will receive the width and the height of the image, and basically we are going to return the image resized. That's it. So now I'm going to need to create a new file called init.find in both folder. Oh, sorry, I remember it. The name of the file and the name of the class. Here is segmenter dataset, and the name of the class is segmenter dataset. The same for preprocessor. Here is simple preprocessor, and the name of the class is simply preprocessor. That's it. I remember create a long init file. That's it. So we have our model to segmentate our image and save the files. Now we need to implement this this graph of files of libraries of classes inside the folder color. The folder color will have or mine from we are going to import our first class. And from FredLab dataset import segmental dataset from FredLab preprocessor simple preprocessor. We are going to import our simple preprocessor. We are going to run this code to try to show if there is not errors. Titan my pi. So we see that there is not errors, but lack implement the next code. So how we are going to implement? How we are going to send? How we are going to receive the paths for the dataset? We need to import the next libraries. We need to import libraries like patch, like other libraries, arguments. So here I have our parts library that will agree to us received arguments from the shell code from the command console. With our parts, we are going to receive all the paths of our dataset and the paths for the output image. We are going to send the paths for the output image folder, and this argument we don't need that. We need this argument like implement another libraries like patch. Here is we are going to use imutils and we are going to test it. We are going to print args dataset and we are going to print output path. For example, in dataset the output will be, for example, this folder exists. I'm going to get the name dataset. As you can see here, I print the name of that patch. The name of the paths were printed correctly. These paths these paths will be sent to our model, to our class segmentar. That's it. How we implement this class? First, we need to create our simple preprocessors, and also I let create this class called image to array preprocessor. This class will use keras to array class. It's very easy. Image to array preprocessor. This will reorganize correctly the dimensions of the image. I'm going to copy this code and I'm going to paste inside preprocessor folder, new file, image to array, p, image to array, image to array, image to array preprocessor. That's it. So now we are going to implement, or we are going to import our class image to array, import image to array preprocessor. So first we create our simple preprocessor, but after that image were segmented, we are going to reimage or resize our image. Basically, is that we can use it or not use. It depends of us. I'm going to resize our image to 227, for example. So after, so then we load. We segmentate our dataset. We need to segmentate our dataset. Main. Here is first we send the preprocessors. First we send the preprocessors, and then we call the method seg is the method that will segment our dataset. But we need to send the paths of the input dataset and the output folder. How we can capture the image is here. Image paths will be sent of this weight, and output directory will be sent of this weight. Remember, our class segmentor dataset receive the image path and the output directory. I have 40 images, and I'm going to set the variables to 10. So now I'm going to try it. The segmentation was made. Sorry, I don't speak English very well, but it means that for end. Proceso terminado. So we are going to test. Let's start. Let's go there. So inside I need to create a folder called oh, dataset. All dataset will contain our images that were segmented. Let's start. Sorry, I have error like a comma. Here we are using TensorFlow like backend. Keras use TensorFlow like backend. If we see our image right, we see that we are using Keras. There is a small sorry, that's it. The images were segmented. We are going to check our folder. We see that there is nothing. Sorry. Here there is a particular problem that we need to create an extra folder. If we see this, if we see the name of the images who were segmented, looks like this. So I see that nothing happened. I don't know why. Probably because our dataset is the name of the correct name of where are the lemons is called limon. We are going to see now the name. Sorry, we have a problem here. That the name result the final image what is like bitwise image final image original there isn't. Now we need to save our original image in the memory to then apply a mask here. Now I'm going to try again, and as you can see, the Python is saving, this class is saving sorry, here also here todavía the problem is this is the problem. We need to create here I printing the paths where will be saved the image, but he say that the paths where the image will be saved say all dataset lemon. We need to create these two folders called dataset and lemon. The name of the dataset and the name of the dataset again. We need to create these two optional folders here inside the old dataset. Old dataset, we create an extra folder called dataset and the name of the folder that contains the lemons is the same name of the original dataset, have the same structure, dataset and lemon inside of old dataset. Now test again, and finally we are going to get the images who were segmented. We are going to check, and as you see here we have all the images that were segmented. We are going to check it inside the folder Python projects, deep learning, descriptors, color, old dataset, lemon, and here we have all images that were segmented without problems. Now we need to try one classifier. How we train a classifier? We are going to try some classifiers like KNN and random forest, super vector machine, and others. I have already created that code. I'm going to copy that code of all classifiers in Clover. Let me see. Inside lemon folder I have that code. I remember that I don't remember where I saved the code. Probably I saved inside classifiers. No. Oh, okay, so inside the scriptures we are going to stop. Okay, guys, the first script that we need is a script that I created as get the features of color. I have created before heraldic scripture. This script I create to me get the heraldic features, but heraldic features are geometrical features like area, centroid, or another of math operations. But heraldic is not used to get the color of the texture. We need to use. I'm going to use the histogram color instead of heraldic. I'm going to copy it. I'm going to paste here, but with another name inside color. inside the main, or not main, no. Main, I'm going to rename with save image. Segmentation process. I'm going to create a new file called get factors, get histogram factors. Get histogram color factors will contain this. I'm going to replace this method with width. With this method. This will be our feature descriptor to get the color histogram. I need to create this variable called bins. Bins for the histogram. What we need here? We need the paths where are our segmented image. Remember that our images were saved inside this folder with the name of dataset and dataset and lemon. And this is the method that we will extract the color histogram. This method receives the image and then that image will be converted to grayscale, and then we get color histogram. We use bins for color histogram, and then we normalize the color histogram and return it. And then we create two variables to save the features and the labels. Here we receive the paths. We read this variable that were specified here. Train paths. We read train paths, and we made the same as before. We look all the image and we read the label of the current image and the current image. This method will check all folder that contain all our image, but we forget to separate these images that were segmented. I'm going to separate that image. Lemon, verde over green. You need to write it with your own Oh, language. I have 20 images, 20 green images for green lemons, and 20 images for mature lemons. Oh, the dataset is very small, but if we can try to apply data augmentation, but probably I'm going to use data augmentation in another opportunity. But so after that we read the name of the current image and the image, I need to get the color histogram features like this. Color histogram. Color histogram was yet this way. I passed color histogram of this way. Inside of our list of features, I say the current color histogram for the current image, and the name of the current image was saved inside the label list. Label list and feature list will be containing our features and our name of the current image. And after I print some message like the shape of the feature vector and the shape of the label vector, and then I encode all labels in label encoder. One hot encode is doing it of this way. Label encoder class is using here label encoder, and then I apply fit transform to convert all labels in a binary way. For example, if our label mature will be converted to 1 hot to 001. If it's green, label the 1 hot label will be 100. This is made to avoid problems with the names of the labels. We could contain labels with the same name, but with one hot encode, that problem is fixed. And then I scale my features with my max scalar, and then I save or file with the features in format the ETF file labels. So here I need to use code of segmentation process like this. I'm going to receive that two names, that two parameters I'm going to receive. The name path will be replaced with arts that input dataset. Dataset with segmented image. Out will be our patch for F5 file. I'm going to replace this code with args output. This will be our patch for save the file. I don't know what means it, but will be better left that. We are going to create a folder called output. Inside of output, we are going to save our features file. Okay, so now let's start. Let's check it. Python get histogram color features. It or dataset. We are going to pass our patch of our image segmented. Remember that inside of our dataset and inside of our dataset we have dataset and lemon, and inside lemon we have our two classes with lemons, the mature lemons and green lemons. And here we are going to check, we are going to get an A and we are going to get the image of every folder. See, it's very easy. And also we don't need past output folder because we handle it of a hand way. We defined here the name of the output folder. And let's start. And good luck. A global feature is not defined. Say we have a small error. To normalize our vector or feature vector, the name is incorrectly. I rename that variable with my own name. I named that variable with characteristics. Characteristics is the correct variable. Check again. I hope successful. We successfully got the features color histogram features. We encode our labels and probably we get these two files, the data and the labels. Data contain our features of color histogram of our image, and labels contain the one hot encode labels. So now we need to use classifiers of machine learning, like KNN and subvector machines, random forest. We are going to try one classifier, but I'm going to test more than one classifier. Here I have some classifiers. We are going to try 3, 4, 5, 6, 7 classifiers: logistic regression, linear discrimination, K-neighbor classifier, decision tree, random forest, and Gaussian naive Bayes supervector machine. I'm going to adapt this code to actual problem. Our actual problem works with only color histogram descriptor. We don't work with hierarchy or hue moments. We only work with histogram descriptor. And I'm going to adapt this code to our context, to our problem. Inside color folder, I'm going to create a file called train classifiers. Inside, I paste my open. Here we are going to use the models of scikit-learn library, decision tree, random forest, KNN, linear discriminate, analysis, Gaussian naive Bayes, and subvector machine. For non-trees, random forest requires the number of the trees. I define here 100, but if we want, we can replace this value with one smaller value or with a higher value. And the size is used to split our dataset. Here I'm going to use 10, but 10 will be the 10% of that image of our segmented dataset. We can define 0.25. Here I am saying that I'm going to use 25% of my dataset. But 25% is a high value to our actual dataset, because my actual dataset only contains 40 images, 24 green and 24 mature. Therefore, I'm going to choose only 10% of that image. 6 is used to electricity. I don't know exactly to what I'm going to use this variable, but is used inside in any place is used this variable. I copy this code from internet. Sorry, this variable is using here. Random state requires the steps. Then I before tried some codes, and I instead 10 I use 0. But if you want you set you could define it, but it's optional. Here I have three variables. The first variable is the results. It's a list the results of the classifiers. The second variable is the names of the labels, and the metric that we are going to use is the accuracy. The accuracy will be used here, and here we read our files of our feature file and our feature or label file that we said before, and this name is the same of that we use here. Here we use dataset1, dataset1. In this file is used that name, dataset1, dataset1. After that we read that two files, we closed that operation. H5F is closed. H delivery H5P agree to use read and write HDF5 files, and then I print some messages like the shape of the feature vector and the label shape, and I print this message that say the train start, and the train starts. Here, before to train, after train, because the train starts here, over here, where we start to train. We start to train our features here of a separate weight. Only here we split our dataset in try data global and test data global or X test X train, and here is our G train and our G test, but I use these names. We can replace these names with our preferred weight. I prefer use these names. This certain data will be 90% because we use 10% to test, and therefore I'm going to, in this variable will be the 90% of the image. Inside this data global will stay the 10% of our image or our feature vectors. Of the same way, here we have our labels to train and our labels to test. After that, we split our dataset. We validate our models with this metric. Remember that we use the accuracy to measure our classifiers. the accuracy will be used here. Here we passed using cross validation. We pass our feature of train to our train features and our labels for train. And we append the results in this list called results and the name of the labels inside names list. And we print the result of the cross validation. And we plot the result. As I said before, we are going to use the color histogram. I'm going to delete these two methods because we only need the color histogram. So we start testing, for example, random forest. But before to test, we are going to try to see what results we get. We are going to see what classifier is better. Classifying all features of color histogram. Let's start. Oh, sorry. The patch, the folder of where are our features is well defined here of a hand weight. We don't pass arguments. We only define the name of a hand weight. Run that script, trying like classifiers. Let's go. What results we are going to get? We see a 10% of precision. That's good. That's very good. That's very good, man. Linear regression, 1% of classification. KNN, 1%. Random forest, 1%. Superior to machine, very bad classifying color histogram features. And then we need to test if that is true. We are going to choose some image and test first. We are going to test KNN or random forest. Random forest will be the first classifier that we are going to test. Let's start. Random forest is a good classifier in this case. Testing our model for random forest. How we test random forest? Very easy. To test random forest, very easy. We need to define first. We need to instance. We need to create our random forest classifier. We call the library, the method of the library, random forest classifier, and we pass the number of the estimators and the random state, and we pass our features to train and our label to train. And where are that images that we are going to test to classify? If if the image contains a lemon mature or a lemon green. We need to copy some image to test. I'm going to copy 5 images to each class. 5 mature and 5 green. I'm going to define that test folder here. Test. I'm going to preserve 5 lemons. 5 lemons. 3, 4, 5. Sorry. 3, 4, 5. Inside. And then the same way. The same. 3, 4, 5. 5 lemons, 5 green lemons, and 5 mature lemons. We are going to test or classify random forest. And good luck. Inside this, we have our 2 classes of fruits. This contains mature and green lemons. We define our 2 labels, and we made the same that before, but only that we are going to only use the color histogram. We don't need heraldic or humans. We only need color histogram method. Color histogram is passed here. And here we predict the current prediction, and we save the prediction inside this variable. This prediction will be a number with the number of the label, of the index of the label. We with the index, and we save that index inside this variable. We read each image of that folder. We get the name, we get the image, and we get the current label for that image. And if we want, I resize here the image, but that image is very small. I'm going to use this same size of our preprocessor. This is optional. Remember that we define 227 and 327 for the simple preprocessor, but here I am using the same pattern, the same dimension. And then we got the features, the current image, and then we get the features. We save that features inside the variable, and we predict these features for the current image with random forest. That prediction for the current image is written here. We are going to write inside the image of the current image the label of the prediction, but to get the name of that prediction, we get the index of the prediction of the label that was predicted. finally I showed that image. I showed the image. So let's check it. Okay. Close it. So no funciona. Doesn't work. Why doesn't work? Probably because I don't know why it doesn't work. I think that here is the problem. The prediction from random forest say that this lemon is mature. That's correct. That's correct. That's correct. That's correct. That's correct. That's correct. Sorry. Here is this prediction is bad. Bad prediction. Bad prediction. True prediction. True. That's true. True. Random forest in this case was very good. One margin of error. The margin for error in this case was very small. Maturo, 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 maturo. Bad, very bad. True, true. What happened if we checked? Naive badges. Let's start. Let's go. So now instead of check random forest, I'm going to check naive badges. What happened with naive badges? What happened with naive badges? That was a good prediction. Very good prediction. The same than before, we read the image, we save the image, we'll say the current label for that image. If we want to resize our image, but in this case I'm not going to resize our image because it was resized before. It's the same with the correct dimension. The same than before, we get that features and we say that features inside this variable, and then we predict that features for the current image, and we say that prediction inside the variable. This variable of the prediction gets the index of the label of the prediction of the image. Here, remember that we have two labels. We have classes, two labels, mature and green in this case. And so now we are going to test it. Let's go to try. Naive badges got a 94%. Oh, it's very good. So let's go into chat. Sorry, test patch say that was not predicted, was not defined. Test patch. Why that I have this variable Here we have our this variable should be stay here. Let's start, and probably now we don't have errors. That's correct. The relation, the most of the classifiers are got a good percent of classification. Again, there is a problem. Haralik say that we only are using one descriptor, the color histogram. Again, test again, and see the results. Remember that we are testing live badges. Filet is not defined. Sorry for that inconvenience. Sorry for that problems. We need to define this library. This library should be defined here. Try again. And this is the result for naive badges. Naive badges, this side mature is that's correct. Good prediction. That's good prediction. Nice, very good. Good, extremely good. That's a good prediction for naive badges. Probably a random forest got a bad prediction because we resize that image. We resize the image. Now I'm going to test again. Random forest. But not resizing the image. I'm going to maintain original size of the image. Resize, no? Random forest, naive badges, sorry. Only receive the name of the image. Before we resize the image, but now we are going to use the original size of the image. Sorry, I have one error. What is the error? Sorry. Here is the error. One comment. Okay, test again. Check. Now we are going to test in random. So naive badges. No, random forest. Random forest got a gut prediction. Now we are going to test random forest and see the results. So we have one error again. This is the problem that I forgot. Remove that line of code. Yes, again. Random forest said here that got accuracy of 100%. But what happens if we test it? That prediction is correct. Here is the problem. I don't know why random forest said mature with a 100 of precision. No, I don't know really. Here is correct. Correct. Is correct. It's correct. But random forest fire is firing. I'm going to mix that image. I'm going to mix with new image. Again, I'm going to use only 5 images. 3, 4, 5. These images are aleatory selection. 3, 4, 5. Now test again random forest classifier. 100% of precision, accuracy, maduro, correcto, correct, that's correct, that's correct. Here's the problem. That's correct, that's correct, that's correct, 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 very good. But naive badges with 6 point less than random forest could get a good classification. If we test again it, we are going to see that naive badges is better than random forest. Test again. Naive badges, maduro, correcto, correct, 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 correct. That's correct, correct, and correct, and correct, and correct. What happens if we get image from lemons from internet, from green lemons from internet? Green lemon. I'm going to choose some image from lemons. And I'm going to see what happens. Two yellow lemons, and this, and test. I'm going to test that image. Inside color, inside test. I don't know what will happen, but probably the current classifier will classify good. I'm going to test again. Naive badges and say that is maduro, and say that is maduro, and say that is green, that's correct, and that's correct. Okay guys, so thanks so much if you if you finish to saw the video. I hope that you learn basic concepts of machine learning classifiers and segmentation preprocessing techniques. That's it. Sorry for that. The language. Yo hablo español. I know hablar English. I don't speak English. Sorry for the language. And that's it. Goodbye.